Hi, my name is Basir. In this video, we'll learn Chapter 12, Applications of Trigonometry from Telangana State Syllabus. So we'll pretty much cover the basics that are required to work on exercise 12.1 problems in this video. And then we'll also complete exercise 12.1. You see a figure here. We have a coconut tree, a palm tree. And Vijaya is standing below the palm tree. She is looking at the topmost position of the palm tree. We'll draw an imaginary line from her eye to the topmost part of the palm tree. This line is known as line of sight. And then we have also, we also see a horizontal line, a line which is parallel to the ground. The angle between the line of sight and this horizontal line is known as angle of elevation. So that's the angle of elevation for you. In this figure, we see that there's a girl standing at the top of a building and she is looking at the base of a borewell. Now, we have drawn an imaginary line here parallel to the ground. So that's our imaginary line, dotted line, which is parallel to the ground. And then there's a line that has been there's a line connecting the girl's eye to the base of the borewell, and that is her line of sight. Now we see that the angle between the horizontal line and the line of sight here is angle of depression. See, if the line of sight is above the horizontal line, so this is our horizontal line and this is our line of sight. If the line of sight is above the horizontal line, then the angle that you get is known as angle of elevation. And if the line of sight is below the horizontal line, then the angle that you get is known as angle of depression. In simple words, if you are looking above, the angle that you get is obviously the angle of elevation, and if you are looking below, the angle that you get angle made by the horizontal and the line of sight is angle of depression. As simple as that. With this knowledge, let us go ahead and solve exercise 12.1 problems. Solving exercise 12.1 problems is pretty easy. Let's get started with this exercise now. So here the question says a tower stands vertically on the ground from a point which is 15 meters away from the foot of the tower. The angle of elevation of the top of the tower is 45 degrees. What is the height of the tower? So you just have to read the question and draw a diagram. That's it, and then you're good to solve the problem. So in this question, it's given here, we have a tower here, and there is this point which is 15 meters away from the tower. So this point, let me write down this point as A. So from this point, which is 15 meters away from the tower, this is my tower. For problem solving, we take we draw a tower as linear, which means we draw it as a straight line. So this is my tower, BC is my tower, right? Now from this point A, which is 15 meters away from the foot of the tower, we are looking at the top of the tower here, and we get an angle 45 degrees. That is what it says in the question, right? Let me read the question once again for you. A tower stands vertically on the ground. So this is my tower, BC is my tower, from a point which is 15 meters away from the foot of the tower. This is my point A, which is 15 meters away from the foot of the tower. So this is foot of the tower, right? Point B is foot of the tower. So from this foot of the tower, 15 meters away from that foot of the tower, which is point A, from this point we are looking at the top of the tower and we are getting an angle 45 degrees. What is the height of the tower? This is the question. So we'll have to find out what is BC. In most of the problems, you just have to apply tan theta and you'll get the values. So let's just apply tan theta here also. Tan theta, we all know that tan theta is opposite side by adjacent side, right? Tan, what is theta? Theta here is 45 degrees. Theta is the angle, it is 45 degrees. Now with respect to this angle which is 45 degrees, this is the opposite side, BC is the opposite side. This slant line is always the hypotenuse, and this is our adjacent side, right? So opposite side is BC. I don't know the value of BC or the length of BC, so I'm writing BC as it is. By adjacent side, what is the adjacent side here? Adjacent side is 15 meters, so I'm writing 15 here. Tan 45, we all know that tan 45 is 1. The value of tan 45 is 1. 15 will multiply here, right? So what do I get? 1 into 15 is equal to BC. So BC is 15 meters, which means height of the tower is 15 meters. That is it. So you just read the question, draw an appropriate diagram for it, and then mostly apply sine theta or tan theta or cos theta based on what you have to find out. We'll work on almost all the problems in this exercise, and I'm sure by the end of this video you will be able to solve the problems on your own. Take it. Now there is one more question. The second question says a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground by making 30-degree angle with the ground. Okay, the distance between the foot of the tree and the top of the tree on the ground is 6 meters. The distance between the foot of the tree and the top of the tree on the ground is 6 meters. Find the height of the tree before falling down. Okay, so this is pretty simple. See, previously we had a tree like this. Again, tree, for problem solving we will take it as linear, which means we'll just draw a straight line representing a tree. So now there was a tree, and then due to storm the tree broke from here. Let's say the tree broke from here, and this upper part, it fell down on the ground like this, right? So the upper part, this upper part, it broke down and it fell on the ground like this. Now this is our ground. Okay, my goodness. There you go. Let me just write it down as A, B, C. So previously this was my tree. From here to here, this was my tree, and then due to the storm it got broken from the point C, and this upper part that you see here, this one, it fell on the ground. It's asking us to find out the height of the tree. So what would be my height of the tree? Height of the tree would be BC, which is this one, and then this part is also part of the tree which fell down on the ground. So BC plus AC will give me the height of the tree, right? Let me write the measurements. It's making angle 30 degrees, so it says that this top of the tree, now this is the top of the tree which fell down on the ground, this is making an angle 30 degrees, and this top of the tree is 6 meters away from the foot of the tree, right? B is my foot of the tree, and A is the top of the tree which fell down on the ground. So this top of the tree is at a distance of 6 meters from the foot of the tree. We'll have to find the height of the tree before it fell down. Okay, so the height of the tree that is BC plus AC. First let me find out what is BC. Simple. Make use of tan theta again. Tan theta is opposite side by adjacent side, right? Tan, what is theta here? Theta is 30 degrees. Opposite side, what is the opposite side here? With respect to this angle, BC is the opposite side. This slant line is always the hypotenuse, and this is my adjacent side, right? So opposite side, I don't know, I'm writing it down as BC. Adjacent side, I know it is 6, so I'm writing 6. Tan 30 degrees, value of tan 30 is 1 by root 3. I'll just cross multiply this thing here. So 1 into 6 is equal to BC into root 3. So 6 is equal to BC into root 3. BC obviously would be 6 by root 3. Root 3 is multiplying. If I take root 3 to the left hand side, it will divide. Now in the denominator we have root 3. I will just rationalize this so that we don't have a root in the denominator. All we have to do is, in the denominator we have root 3, right? So we have to multiply and divide this thing by root 3. 6 into root 3 is 6 root 3. Root 3 into root 3 is root 9. What is square root of 9? Square root of 9 is obviously 3. 3 ones are 3 twos are. So value of BC is 2 root 3. Value of BC is 2 root 3. Right. Now when you know two sides of a right angle triangle, it is obviously easy to find out the third side in a triangle, in a right angle triangle, using Pythagoras theorem, right? So the Pythagoras theorem here would be AC square is equal to AB square plus BC square. I don't know the value of AC, so I'm writing AC as it is. AB is 6, BC is 2 root 3. AB is 6, BC is 2 root 3, right? 6 square is how much? 36. Square, it goes for 2 also, in square, you know, it goes for root 3 also. 36 plus 2 square is 4. Square and square root gets cancelled. 36 plus 4 into 3 is how much? 12. 36 plus 12 will make it 48. I'll have to take another sheet here. Let me just take another sheet. So the value of AC square is 48. That's what I see here. AC square is 48. AC will be, if I take remove square root from the left hand side, I'll have to put a, if I remove square from the left hand side, I'll have to put a square root on the right hand side. Square root of 48. How do I do this? Let me just take LCM of this. 2 24s are 48, 2 12s are 24, 2 6 are 2 3s are 3 1s are, right? So 48 I can write it down like this: 2 into 2 into 2 into 2 into 3, right? These two same numbers I can take it as 1 outside the square root. 2 2s are 4, 4 root 3. So the value of AC that I see is 4 root 3. Now we actually wanted to find out the height of the tree before it fell down, and we see that the height of the tree should be BC plus AC, right? What is the value of BC? The value of BC is 2 root 3. Take care. Value of BC is 2 root 3 and value of AC is 4 root 3. 2 root 3 plus 4 root 3 will make it 6 root 3. So the height of the tree is 6 root 3 meters. As simple as that. Let us go ahead and work on the next problem. Problem number 3. Again, we just have to read the question and we'll have to draw a right angle triangle based on accordingly based on the question. A contractor wants to set up a slide of the children to play in the park. Take care. He wants to set it up at a height of 2 meters and by making an angle of 30 degrees with the ground. What should be the length of the slide? See, this is simple. This guy is saying that he wants to set up a slide here, a slide like this, and he wants to set up the slide at a height of 2 meters. So this height is 2 meters. The height of the slide is 2 meters, and this slide is making an angle 30 degrees with the ground. This is my slide, right? let me just name this. This becomes a right angle triangle. I'll name it as ABC. Take care. What should be the length of the slide? So this is what I need to find out. I need to find out AC, because AC is the slide. They are asking us to find out the length of the slide. Take care. Now this is something that I have told you in my previous videos. If you want to remember the ratio sine theta, cos theta, tan theta, all you have to do is you just need to remember this. Old Harry and his old aunt. So old Harry and his old aunt will help you in remembering the relationship between the sides and the angles in trigonometry. For me, this O means opposite side, and H means hypotenuse. A, here the first letter A is adjacent side for me. The first letter H is again hypotenuse. O is opposite, A is adjacent. So sine theta is opposite side by hypotenuse, cos theta is adjacent side by hypotenuse, tan theta is opposite side by adjacent side. Now if you look in the figure, with respect to this angle 30 degree, BC is my opposite side, this slant line is always the hypotenuse, and this is my adjacent side, right? In the question, they have given us the opposite side, which is 2 meters, and they are asking us to find out the hypotenuse, right? So opposite and hypotenuse, opposite by hypotenuse, where do you find it? Opposite by hypotenuse, you see that sine theta is opposite by hypotenuse, opposite side by hypotenuse. So I'll make use of sine theta. Sine theta is opposite side by hypotenuse. Sine, what is theta here? Theta is 30 degrees. Opposite side, what is the opposite side here? BC, which is 2, right? And then hypotenuse is AC. I don't know what is the value of AC, so I'm writing it down as it is. Sine 30, everybody knows that sine 30 is 1 by 2. Now I'll just cross multiply. 1 into AC is equal to 2 into 2. I'm just cross multiplying this here like this. So value of AC is 2 2s are 4. So value of AC is 4, which means the value of the slide, the length of the slide is 4 meters. Therefore the length of the slide is 4 meters. As simple as that, right? Let me go ahead and work on the next problem here. Problem number 4. Problem number 4. Length of the shadow of a 15-meter high pole is 5√3 meters at 7 o'clock in the morning. Then what is the angle of elevation of the sun rays with the ground at the time? Okay, I believe this is simple. The question here is the length of the shadow of a 15-meter high pole. So there is a 15-meter high pole. So this pole right here, this is my pole here, which is 15-meter high, and then it is casting a shadow here on the ground. On the ground, the length of the shadow is 5√3 meters, right? That's what it says. I'll have to find out the angle of elevation. Let us just find out this angle. I'll just make use of tan theta. Let us suppose this angle is theta. Tan theta is opposite side by adjacent side. Opposite side is 15, adjacent is 5√3. If I have to remove square root from the denominator, I'll just have to multiply and divide this thing by root 3. 15 into root 3 is 15√3 by this 5 I'm writing as it is. Root 3 into root 3 is root 9. 3 3s are 9. 15√3 by 5 into square root of 9 is what? 3. 5 3s are 15. This 15 and this 15 gets cancelled. I end up getting tan theta as root 3. The value of tan theta is root 3. So theta should be 60 degrees because tan 60 degree is root 3. Therefore the angle of elevation should be 60 degrees. I'll skip the fifth one. I believe you should be able to do it on your own. I'll do the sixth one now. Sixth one, it says, suppose you are shooting an arrow from the top of a building of an height of 6 meters to a target on the ground at an angle of depression 60 degrees. What is the distance between you and the object? Simple. So I'll first draw a building here. Again, for problem solving we consider it as linear, right? A straight line. Okay, let's say this is our building. Suppose you are shooting an arrow from the top of a building at an height of 6 meters. So this building at a height of 6 meters, let's say you're standing here at a height of 6 meters, and then you are shooting a target on the ground. Let's say this is our target on the ground, and I'm drawing a horizontal line, and this is my line of sight. I'm shooting this target on the ground. Okay? The angle between this horizontal line and this line of sight is known as angle of depression, and the angle of depression is given as 60 degrees. What is the distance between you and the object? This is me, and this is the object, right? So I'll have to find out this distance, this one. Let me just join this. This becomes a right angle triangle. I'll name it as A, B, C. So we have to find out AC. We have to find out the value of AC. Now you just have to remember that this line here, this one, and this line here, they are parallel, and this actually becomes a transversal. So if this angle is 60 degrees, this angle also have to be 60 degrees because they are alternate angles. Now with respect to this angle which is 60 degree, this is the opposite side, this is the adjacent side, and this is the hypotenuse. So I have to find out the hypotenuse. We know that sine theta is opposite side by hypotenuse. Sine, what is theta? Theta is 60 degrees. Opposite side is 6 meters by hypotenuse. I don't know hypotenuse. AC, I'm writing AC as it is. Sine 60 is root 3 by 2. Just cross multiply here. Root 3, sorry. Root 3 into AC should be 2 into 6. So value of AC should be 2 6 are 12. 12 by root 3 is multiplying, root 3 will divide here. Again, as I told you earlier, if we have to remove root 3 from the denominator, we just have to multiply and divide this thing by root 3. So I am multiplying and dividing by root 3. 12 into root 3 is 12 root 3. Root 3 into root 3 is root 9. Square root of 9 is 3. 3 ones are 3 fours are. So value of AC is 4 root 3. Value of AC is 4 root 3, which means the distance between you and the target is 4 root 3 meters, right? My mom is calling me to have breakfast. Just one second, I'll pause the video and I'll come back. Okay, so the seventh question says, an electrician wants to repair an electric connection on a pole of height 9 meters. Okay, so we'll draw a pole of height 9 meters. Again, as I told you, for problem solving we usually take pole as linear, as a straight line. So this is my pole, which is 9 meters. Okay. He needs to reach 1.8 meter below the top of the pole to do repair work. Now this guy is climbing on an electric pole which is 9 meters high, and then he needs to reach 1.8 meter below the top of the pole to do repair work. What should be the length of the ladder which he should use when he climbs it at an angle of 60 degree with the ground? What will be the distance between foot of the ladder and foot of the pole? So this is simple. There is an electric pole which is 9 meter high, and this guy is climbing down 1.8 meter below. So let's say this is 1.8 meters. This thing from here to here, this is 1.8 meters. So he is climbing down 1.8 meters, and then they have placed a ladder like this, which is making an angle. What is the angle it is making? It is making an angle 60 degree with the ground. So it's making an angle 60 degree with the ground. They are asking us to find two things. What should be the length of the ladder? This length. This is my ladder. So we'll have to find out the length of the ladder, and then we have to find out the distance between foot of the ladder and the foot of the pole. Let me just name it like name this way: A, B, C. This point I'm naming it as D. So from the diagram we see that there is a 9 meter high electric pole, but to fix the connection, this guy needs to come down 1.8 meters. So now BC, this BC would be 9 minus 1.8, because this complete pole BD is 9 meters. Now this guy is coming down 1.8 meters, so I'll subtract 1.8. Now this BC should be 9 minus 1.8, which means BC should be 7.2. 7.2. So this BC is 7.2. As always, let us make use of tan theta here. Tan theta is opposite side by adjacent side. I hope you got the diagram. In case you have any questions, any queries, as always, feel free to post them as comments on YouTube. I'll read your comments and I'll get back to you. Tan theta. What is theta? Theta is 60 degrees. Opposite side. With respect to this angle 60 degrees, this is the opposite side. This slant line is the hypotenuse, and this is the adjacent side, right? So opposite side is 7.2 by adjacent side, I don't know. I'm writing it as AB. Tan 60 is root 3. Root 3 is 7.2 by AB. So AB into root 3 is 7.2. AB should be 7.2. Root 3 is multiplying, so root 3 will divide. Again, you just have to rationalize the denominator so that root gets removed from the denominator. Root 3 into root 3 is how much? Root 9. What is square root of 9? Square root of 9 is 3. I'm cancelling this thing. 3 2s are 6. 3 4s are 12. 2.4 root 3. So the value of AB is 2.4 root 3, which means the distance between the foot of the ladder and the foot of the pole is 2.4 root 3 meters. Now let us find out AC. Let us find out AC. AC I can find it out using by two methods. Now that I know two sides of a right angle triangle, one side AB is 2.4 root 3 and the other side BC is 7.2. I know two sides of a right angle triangle, so I can make use of Pythagoras theorem. AC square is equal to AB square plus BC square. Or else I can let me just make use of Pythagoras theorem to find out the value of AC. So according to Pythagoras theorem, AC square should be AB square plus BC square. AB is 2.4 root 3 and BC is 7.2. AC square is, this square will go for 2.4 also, and I'll take the square on root 3 also. ठीक है, 2.4 square Let me just use a calci here. I really don't want to do those calculations. I mean, those are pretty easy, you can do it on your own. 2.4 into 2.4, that should be 5.56, I believe. 5.76, yeah, 5.76. so 5.76 into this square, and this square root gets cancelled. I get 3 here. 7.2 square means 7.2 into 7.2, right? 7.2 into 7.2, right? 51.84. 51, oh my goodness, let me just write it once again. 51.84, right? Now AC square is 5.76 into 3, okay? 5.76 into 3, that is 17.28. 17.28 plus 51.84. Let me just add 51.84 here. 51.84. This becomes 69.12. So AC should be square root of 69.12. 69.12. I don't think this is a perfect square, so we'll have to make use of long division method to find out the square root of it. 69.12. Instead of showing all this, I believe I'll just use a trigonometric ratio. So this is one way of doing it. You know, two sides of a right angle triangle, you can pretty much use Pythagoras theorem to find out the third side. But since 69.12 is not a perfect square, we'll have to use long division method, you know, to find out the square root of it. But instead of doing this, let me just, you know, show you how to use a trigonometric ratio to find out the value of AC, to find out the value of hypotenuse. Okay, so the second way of finding out the length of the ladder is just to make use of a trigonometric ratio. I'll make use of sine 60 degree. Sine is opposite side by hypotenuse, right? Sine is opposite side by hypotenuse. Sine 60 is root 3 by 2. What is the opposite side here? 7.2, and hypotenuse is AC. I don't know the value of AC, so I'm writing it as it is. Cross multiply this thing. AC is 7.2 into 2 by root 3. I'll just rationalize the denominator, which means I'll have to multiply and divide this thing by root 3. Root 3 into root 3 is root 9. Square root of 9 is 3. 3 1s are 3. 3 2s are 6. 1 is remaining. This becomes 12. 3 4s are 12. 2.4 into 2 is 4.8. 4.8 root 3 meters. Therefore, the length of the ladder is 4.8 root 3 meters. Right. Now let us go ahead and work on the next problem here. I'll go ahead and skip this 8th problem. I believe you should be able to do it. At least I should give you one problem to try it on your own. I'll be doing the 9th one here. The question says an observer of height 1.8 meter is 13.2 meters away from a palm tree. Again, for problem solving purpose, we will draw a palm tree as linear, as a straight line here. So let's say this is the palm tree, and this is the observer here. So this guy is the observer here. I'll just name it as AB. So observer AB is looking at a palm tree CD. I've named the palm tree as CD. So this observer AB is looking at the top of the palm tree. He's looking at the top of the palm tree, right? Let's say this is the ground. It says in the question, the observer is looking at the top of a palm tree, and this guy, the observer, is 13.2 meter away from the palm tree. Height of the observer is 1.8 meter, and this guy is 13.2 meter away from the palm tree. ठीक है. So I'll just go ahead and draw a line parallel to the ground here. Let me just name this point as E. In the question, it's asking us to find out what is the height of the palm tree, and the angle of elevation from the top of this guy's eyes to the top of the tree. This elevation, it says that it is 45 degree. They want us to find out the height of the palm tree, so I'll have to find out the length of CD. CD is my palm tree, right? If this if you carefully look at this diagram here, A, B, E, C, it looks like a rectangle, and in a rectangle the opposite sides should be equal. So if AB is 1.8, then EC should be 1.8, right? EC should be 1.8. We consider this triangle here. Consider triangle BDE. We consider this triangle BDE, and we just apply tan theta here. Everybody knows that tan theta is opposite side by adjacent side. Tan, what is theta? Theta is 45 degree. With respect to this angle, this is my opposite side, so which means DE is my opposite side, BD is the hypotenuse, and BE is the adjacent side. So opposite side DE, I don't know, so I'm writing DE as it is, by adjacent side, see, ABC, it becomes a rectangle, right? So if this is 13.2, then this also should be 13.2. Opposite sides of a rectangle should be equal. So my adjacent side now, it is 13.2. Tan 45, we know value of tan 45 is 1. So DE should be 1 into 13.2. So DE is 13.2 meters. So this DE, this measurement is 13.2. The height of the palm tree should be CD, which means this much 13.2 plus this much is 1.8. So 13.2 plus 1.8 should give you the complete height of the palm tree, right? DE, from here to here you get it as 13.2, and from here to here EC you have 1.8. so the total should give you the height of the palm tree. So the height of the palm tree is 15 meters. 10th one, also I'll just go ahead and skip. I believe you can do it on your own, you can try it on your own. I'll just tell you the procedure how to do it. With respect to this 30 degree angle, we see that BC is the opposite side, AB is the adjacent side, and AC is the hypotenuse. Just make use of sine trigonometric ratio. Sine 30 degree should be BC by AC, right? Or else I'll just do it. I believe showing you by doing it is a little bit easy than just orally explaining it. Okay, this is how it is. A, B, C. AB is 5 centimeter. Angle A is 30 degrees. AC is 6 centimeters. Find the area of the triangle. Angle B here is 90 degrees. Everybody knows that the area of the area of the triangle, area of a right angle triangle, should be half base into height, right? So if this is right, if angle B is 90 degree, then the base should be BC and the height should be AB, but I don't know the value of BC, so I'll make use of sine here. Sine is opposite side by hypotenuse. For 30 degree angle, this should be my opposite side, this is my adjacent side, and this slant line is always the hypotenuse. Sine 30 is half. Opposite BC I don't know, so I'm writing BC as it is. Hypotenuse I know it is 6. 6 is dividing on the right hand side, so it will multiply on the left hand side. 2 1s are 2 3s are, so the value of BC is 3 centimeter. Value of BC is 3 centimeter. Area would be half base into height. Half, what is the base here? BC is the base, and height is AB. Half base is BC. BC is 3 into AB is 5. 3 5s are 15. 15 by 2 is 7.5. So the area of this triangle is 7.5 centimeter square. With this, we have completed our first exercise in this chapter, which is 12.1. In the next video, we'll go ahead and work on the next exercise. If you have any questions and concerns, as always, feel free to post those questions as comments on YouTube. I'll read the questions and concerns and I'll get back to you. So until next time, goodbye.